First, let's talk about numbers. And we have something called sets. They're sets of numbers. Okay. One set of numbers is called natural. Natural set of numbers starts with 1, 2, 3, ... The whole numbers, they start with 0. ... Exactly 3 dots. Also, we have something after that called integers. The integers start with ... -2, -1, 0, 1, 2, ... 3 dots. Now, we normally put braces around sets of numbers. The natural start with 1. The whole, same thing, but they start with 0. The notation for a set is whatever you put inside, but it's flanked, if you want, by parentheses. These are called brackets. I'm sorry, these are called braces. By braces. We have 3 grouping symbols: parentheses, brackets, and braces. These are braces. So a set of numbers, the set of natural numbers, braces, 1, 2, 3, ... This does not mean 3.9 or 4.2. No, it says, well, this is the pattern. One more. So 4, 5, and so on and so forth. The same thing here for whole numbers. Same thing here for integers. Now, the next one is rational. The set of rational numbers. The set of rational numbers is everything you see here, everything, and in addition to m over n, any ratio such that m and n are integers. But there is a problem. So m and n are integers. But there is a problem. This number cannot be 0. So as you notice, this one is here. These 2 are also here. This one can be written as a fraction. Anything here can be written as a fraction. How come? Well, -2 can be written as -2/1. 0 can be written as 0/1. It's still 0. 1500 can be written as 1500/1. So all integers are also rational numbers. Okay, and there is a bigger one, real numbers. Well, real numbers have 2 different types of numbers here. Rational, of course, and irrational. So basically, everything you see here is a real number because it's included in rational. This is included here, this is included here, this is included here. And irrational, what is irrational? Something that cannot be presented as a fraction with no approximations. Okay? So for example, irrational numbers, stop me if you have questions anytime. So irrational numbers are pi. Pi is an irrational number. The square root of 3 is an irrational number. The square root of 2 is an irrational number. All these numbers cannot and will not be presented as a fraction with no approximations. So basically, we have a big set called real number set, we have rational, we have irrational. Inside rational, we have integers. Inside integers, we also have whole. And inside somewhere here, we have natural. So all this piece is rational. They can be integers, they can be whole numbers, they can be natural, or simply 1/3, 1/2, 2/7. But here, on this side, we have irrational, like pi, or e, or the square root of 3, or the square root of 2, and so on and so forth. Good. Now, how do I plot these, let's say, integers? Because rationals are more difficult, and real, or I should say irrationals, are more difficult. Now, how do I plot integers? Plotting integers on a number line. Plotting integers on a number line. So 0 is not considered positive and it's not considered negative. How does a number line or a real line look like? It has 0 in the middle. It has negative infinity on one side. It has positive infinity on the other. And now it depends on the scale. For example, let's say this is my scale. It's a unique distance from the tick marks on the real line. So for me, these are 1 unit. They can be 10 units, they can be 15 units, but let's say they're 1. How do I plot -2? Here's my -2. How do I plot +3? 1, 2, 3. Here's my +3. And so on and so forth. How do I compare integers? Everything that is to the right, it's bigger than it's to the left. So for example, what if I have -3 and 1? I know it's a silly question. Which one is smaller? Obviously, here is -3, and here is +1. So obviously, -3 is less than +1, because -3 is to the left of 1. How do I compare 1 and 3? Where obviously 1 is less than 3. Or I can say the other way. 3 is greater than 1. 3 is greater than 1. This is greater than. So we have inequality symbols, and there are four inequality symbols. Four inequality symbols. So greater than, this number is greater than this number. Less than, this number is less than this number. But we can also have greater than or equal to, or less than or equal to. So here, another example. Is 3 less than or equal to 3? The answer is yes, because one of these two is true. 3 is not less than 3, but 3 equals 3, so this is correct. 3 less than or equal to 3. The equal part is true, so then the whole statement is true. Is -1 greater than 2? No. Negative 1 is not greater than 2. Negative 1 is less than 2. Okay, as I was mentioning, we have braces, we have brackets, and we have parentheses. Braces, brackets, and parentheses. We also have absolute value symbol. What is the absolute value symbol? First of all, there is a mistake in the video for this class. This is not a grouping symbol. These are grouping symbols. Absolute value symbol is not a grouping symbol. How does it look like? And what does it mean? Two vertical bars. Let's say I have -2. Let's say I have 4. And let's say I have the absolute value of 0. The absolute value of -2 is the distance between 0 and -2. And the distance is 2 units. What is the absolute value of 4? The same thing. It's the distance between 0 and 4. So that's why this is 4. Can anyone help with the distance between 0 and 0? Don't forget you are muted.
0.
Indeed. So what happens if I put a minus in front here? It's a different story. But I am not allowed to distribute or do anything with it. That's why this is not a grouping symbol. We cannot apply the same rules that we apply to grouping symbols to the absolute value symbol. That's why the absolute value is not a grouping symbol. Okay. I would like us, before we continue, I would like us to look at some problems. Anybody, any questions? Any questions?
Oh,
Yes.
I don't know if I heard this right, but are you able to, like, obviously to just record what's going on in the class, like in your screen, or you just have to just only take notes?
Oh, I'm so
If
sorry. I was sharing my screen. Oh, I'm so sorry.
oh yeah, I was
Oh, I'm so sorry. I just realized that I was sharing my screen. I should have not. I just want you to see this. I'm sorry. Don't let me make that mistake. I'm getting carried away.
yeah,
Okay,
no worries.
so do I have to go back and explain any of this? Maybe I should. Okay, sorry about that. Sorry. Don't let me share my screen when I shouldn't. I didn't realize. Yes, Silas, you had a question. Go ahead, please. You're muted.
Can you hear me?
Yes, now I can.
Okay, thank you. Similar to what Daniel was asking, like, are you going to record the classes or, like, so for example, if I want to check back later and see like a recording of something I may have missed, am I able to do that or no?
Okay. So let me show you how the recordings will look like. So I have been recording my lessons in the last more than 15 years. So this is a class that I teach almost every semester. It's a calculus class. And did you just came in?
I did not make it to class on time
That's okay.
because of my work
That's,
schedule,
that's okay. No
but I was
worries.
here like 45 minutes ago.
No worries.
45, 50
No
minutes.
worries. Okay. So you're going to have at the very top in your class, you're going to have a big module entitled I'm not sure what is my computer doing now. I can't. Okay. Okay. So video lectures and lecture notes, in our case, it will be spring of 2026. All the lectures will be presented with a PDF file that I'm writing on. So this will be uploaded, and all the videos will be also uploaded, and it will look like this. The link is up here. Don't look at this and say, oh, it's not working. All the links are up here. And that's how it will look like. You can watch it on any device. They will be uploaded in YouTube. You can scroll back and forth. When we looked at my intro, I showed what my students recommended, that you always do that. You always go back and watch the video and look at the PDF file and work on the problems that we do in class diligently all the time. This is how it will look like. Does that answer your question?
Yes, perfect. Thank you so much.
Thank you. Okay, so my apologies. Now I have to start from the beginning. Sorry. Just a quick. I will post all this, of course, but I'm so sorry that I was sharing the screen unbeknownst to me. Sorry about that.
Well, I saw the screen the entire time. Like what you showed your hands the entire time.
Yeah, but it was probably a tiny little thing. I'm sorry.
It was huge.
Okay. So do I have to go back? Does anyone need me to go back over this? Does anyone need that? Okay. Does anyone need me to go over this? Okay, perfect. So then we are ready to work on some problems. Excellent. If I have to go back to anything, you always stop me. And don't let me share my screen when I shouldn't. It's not your obligation, it's my obligation, but sometimes I get carried away thinking of what I need to talk to you about. No excuse, no excuse. Okay, I'm back to our class because I had to show the other one. Okay. So now I'm opening a preview of the first assignment. Now I am sharing. Okay. So all assignments are different. What I'm going to click on will be different than what you're going to see. And I just want us to look and see and select some problems from here and work on them. And I will stop sharing. Okay, so we have a bunch of numbers here, and you will tell me whether we have to write this down or not. So which of the following numbers are integers? Integers. Remember, integers are from negative infinity to infinity, but they have to be whole numbers, positive or negative, or 0. So what will you say about -3/7? Is it an integer or not?
No.
No. What about 0?
Yes.
Perfect.
Yes.
What about 13/7?
No.
No, it's not an integer, but what would you say it is?
It's irrational.
It's a rational because it's a fraction with no approximation. It's rational, and it's also real. It's a real number. Everything is real, right? Unless we expand that to complex numbers, but for now we're going to say real is our world. So this is a real number, and it's a rational number, but it's not an integer. What about -1,000?
Yes.
Yes, -1,000 is an integer. It's a real number. Is it a whole number? No, because it's negative. Is it a natural number? No, because it's negative. What about 61? Is 61 an integer?
Yes.
Yes. Is it a whole number?
Yes.
Yes. Is it a natural number?
Yes.
Is it a rational number?
Yes.
Because it can be written as a fraction with no approximation, 61 over 1. Perfect. Is it real?
Yes.
Yes, everything is real. Negative 7/4. Is it an integer?
No.
No, because it's a fraction.
Correct.
It's a rational number. It's real. It's real, rational, but not an integer. What about 12 divided by 4?
No.
12 divided by 4.
I mean, kind of, yes. If you play it out,
You have to divide it. What do you get?
you get 3.
Yes, we get 3, so this is an integer. It is a whole number. It is a natural number. It is a real number. It's a rational number, and it's also real. The same thing for 3, with 3. Good. Do we all understand this? Okay, moving on. A shipwreck was discovered at a depth of about 69 feet below sea level. What integer would you say it describes 69 feet below sea level?
Negative 69?
That's it. Write the integer that corresponds to the following situation. 110 degrees Fahrenheit above 0.
110 degrees?
Yes, we're going to say plus because it's a positive. But you're right. Writing 110 degrees with a plus or nothing, it's very clear. Both of them are correct. On the number line, plot the points whose coordinates are. Do we have any difficulties with this, or do we understand? Do I have to show it?
Clear.
You want me to show it?
No, that's clear.
Okay. Let me know.
Could I ask you a question?
Always.
Are we supposed to be doing this along with you, or are we just watching your screen
No.
and helping?
No.
Okay.
In the future, very good question. In the future, I'm going to show a few examples, and then you want to work. We're going to work on independently for a few minutes on your own. If you encounter something, you'll say, I need help on this problem, and then we'll continue. It's just that today we had to spend a lot of time on how to continue. Okay, that's fine. Okay, so let's talk about this. Now, the absolute value of -3 and the other, yes, yeah, I'm gonna stop sharing. I just wanted to copy it first.
Oh.
So the absolute value of -3 is the distance between 0 and -3. And we know that this number is 3. Now, that's why this is not a grouping symbol. First, we have to evaluate this. So what does that mean? What is the absolute value of -2? 2. Well, when we multiply, and we haven't discussed this yet, when we multiply 2 by -1, because basically this is something like this, -1 multiplied by the absolute value of -2. We determine that this is 2, and then we have to multiply -1 by 2. When we multiply a negative by a positive, unlike signs, the answer is always negative. So when we multiply 2 negatives, the answer is positive. When we multiply 2 positives, the answer is positive. But when we multiply opposite numbers, depending on how many we have, but let's say only 2, negative times positive, this is negative. In any order, positive times negative. But what happens if I have 3 negatives? That's a different story. But whenever we multiply 2 numbers with like symbols or signs, the answer is always positive. When we multiply two numbers with opposite signs, the answer is always negative. Therefore, 2, there is no symbol here. There is no operation symbol. Well, we always assume it's multiplication. Otherwise, it will be clearly stated as positive, negative, or division. If the symbol is missing, we have to assume it's a product. So that's the product symbol or multiplication. When we say product, we mean multiplication. When we say multiplication, we mean product. Good. So then the answer here is -2. Not because these are grouping symbols. They're not. Normally, if we have this situation with parentheses, not absolute value, this answer is +2 because I am multiplying an invisible -1 by -2 when I get a positive number. But this is with a grouping symbol. But this is not a grouping symbol. Therefore, we have to perform this operation first and then multiply the result by -1. That's why it's a mistake when you watch that video in the Learn assignment. The professor would say that the absolute value is a grouping symbol. It's not. So that's an error there. Okay. Okay. Okay, so here we have to enter the correct symbol. Okay, so between 2 and -3, which symbol would you use? Greater than or less than?
Greater than.
Greater than, because 2 is a positive number and -3 is to its left. What about here? Position in your mind where -4 is and where -3 is. Which symbol will you use?
Less than.
Less than. Do we all agree with less than? What about -2 and 0? Position in your mind where
Less.
less than. Very good. What about -2 and -3? Position. Yes, because -2 is to the right of -3. So this is 0. This is -2, and this is -3. So -3 has to be less than -2. Anything is to the left, that is to the left, is smaller than what it is to the right. So picture these two, realize that -3 is on the left, so -3 must be smaller than -2. Okay?
Yeah.
Good. Rewrite the statement, you can read it. So yeah, this is a good example. So we used this before a few minutes ago. Is 23 is less than 24. But I can also, and this is extremely important for later on, I can read the statement from right to left. 24 is greater than 23. So we have two ways of presenting this. 23 is less than 24, or 24 is greater than 23. Both ways. And this is good for later on inequalities. Okay, the same thing. You find the correct. Okay, the same thing. There is a lot of repetition. Yes. Good. So everything from problem 1 to problem 12, not 13. So problems 1 through 12 in the homework have to be completed before class on Tuesday. And you have to look at the same problems. No, not the same problem. Sorry. Only the following learning objectives. So in the learning objectives, I did not manage to finish, but that's okay. We really needed that. So we finished the identifying integers, we finished the plot integers, we finished the compare integers, and we finished the compute the absolute value of a number. So that's all you need to complete for Tuesday class and the assignments, the first 12 questions, right? So they learn only these 4, and from the assignment 1.1, only problems 1 through 12, because that's all I achieved today. I did not achieve more than that. So the video will be posted.